So hello everyone. I tried to run an experiment. Can you hear me? If you can hear me, please type in the chat. Yes. Okay. Great. Thank you. So I tried to work with Hopin a bit and to make my setup work better, but I think the experiment failed. So I am sorry for the image in the image. So when you see the image in the image, I'm actually active on the Hopin page. But let's start with the workshops. So let's see, we have about 20 people in here, I think, or no less. Yeah, so until we start, if you direct your attention, I'm not sure if you've been to the other sessions, but you take a look at the right side, you should see the session tab. And if you click on the session tab, you can access 4 other sub tabs. That's chat, polls, people, and Q&A. And I'll try to make this interactive. This is a workshop after all. So it's best if we have a way to communicate bidirectionally. So I have the microphone and I have the screen. And but from your side, unfortunately, we're going to have only typing into the chat. And we'll be using, I don't know, just let's greet, I know, hi again. Let's just warm up a bit. So just say hi in the chat, please, if you hear me. Okay, great. Hi guys. Welcome and nice to see you here. So we'll be using the chat. Then we'll also use the polls tab. I'll tell you exactly specifically why we need that. And then if you have questions during the presentation, please post them in the Q&A tab. So if you go to Q&A and press on ask a question, you will get a more organized form of asking a question, so that we do not go over that question without answering, or so that the question won't go unnoticed if you just put it in the chat. Right? Agree? Good. Okay. So let's start. So hi again and welcome. My name is Alex Malesh. And today I'm going to talk about cryptocurrency and more about the technical side of cryptocurrency. So we'll put away all the market hype, all the things that are related to the price of cryptocurrency, and you probably heard about it. If you're not active in trading and investing, I'm sure you heard a lot about from traditional media articles about crazy things that are happening in cryptocurrency. So, and in a way, that's how the traditional mentality sees what's this whole experiment, right? They see them as the magic internet money. That means like La La Land money, like money that don't have actual value. And if you take it honestly and dissect exactly to the definition of money and what makes something valuable and what properties money should have, you can see that these two phenomena of traditional money and cryptocurrency or decentralized money converge at some point. And what's very interesting, that soon we'll see that this conversion will result in a competition, and it's always good to have two options, right? When it comes to money, when it comes to politics, when it comes to anything, and let the people choose what they want to use for case-by-case scenario, right? Okay, but besides that, besides the money aspect, we're going to look into how to create tokens on Ethereum blockchain. So this workshop is I have divided it into 2 parts. So the first part is more introductive, theoretical part. I won't insist much in there, but I think we need the basic notions of what a blockchain is and how Ethereum works, what a smart contract. We'll take a look at the Solidity programming language, and then we'll start actually using it and programming the cryptocurrency. So in the second part, we'll create our own cryptocurrency live today in the 1.5 hours that were allocated for this workshop. Okay, cool. And that means that, and in order to make it more interactive and more fun, I would recommend at some point for you to install a very simple wallet. Everything that you'll need is just a simple browser. You'll install an extension, and if you follow 3 or 4 simple steps, then the cryptocurrency that we will create will be distributed to the people who would complete these 4 simple steps, right? Okay, cool. So that being said, let's get going. Okay. Great. So about public blockchains and cryptocurrency in general. So what is crypto? Give me 1 second. Okay. So what is crypto? Cryptocurrency in general refers to value tokens, and usually we do have 2 types of cryptocurrency. They are referred, the community has called them coins and tokens, right? But if we take the early blockchains like Bitcoin blockchain, we'll see that it has a native value currency, which is Bitcoin. It has the same name as the Bitcoin network, right? The network is written with a capital B, and the Bitcoin, the coin, is written with lowercase. And then we have the functionality, or what's the use of Bitcoin just inside the Bitcoin network. So the main use case is that the miners who mine those complex problems, how the traditional media calls them, so the miners get rewards in Bitcoin just for securing the network, just for putting at expense, energy, and hardware to make the network secure. And then the other use case is the fact that it is used as a transaction fee. So this is very good for prevention of spamming. So for example, if you have a network that asks for no fees at all, people will probably spam it at some point if they see value in it, right? So this is against spamming and against what's called Sybil attacks. Okay, and then we have other types of networks like Ethereum. Ethereum has its own native value currency, which is called Ether. And we'll also take a look at Polygon, because Ethereum currently, or Ether currently, is very expensive. We'll use Polygon as a blockchain, which has its own native value currency called Matic. Okay, but now besides the native coins, there are also tokens. Tokens are that's what we'll be actually we'll be creating today. So we'll create an ERC20 token. I'll explain what's ERC20 and so on. And it will act, and it will have the same functionality as any type of currency. As Ethereum or Bitcoin, it will have the basic functions like querying how many tokens I have in my wallet, transfer it from my wallet to another person's wallet, and so on. Okay, good. So back to Bitcoin and Ethereum. Usually, you have so we have the addresses that identify accounts. So in Bitcoin, you have addresses that have a given format. You see the string below in the lower part of the screen. So this is just base 58 format. That's basically base 64, but they have eliminated some characters that look alike, so like digits and letters, like let's say 1 on capital I, or O and 0, and a few digits and letters that look alike. And it's possible to introduce errors when you copy it manually from the screen on paper, or you just type it looking at the paper and you type it to the screen, right? So that was the whole reason. And then Ethereum has another format of addresses, and it's a totally different blockchain. It has nothing to do with Bitcoin, and it conserves. It works on the same principles, but it does it's I think totally differently than Bitcoin does it. And an Ethereum address looks very much like you have it prefixed with 0x, and then you have a string of characters with hexadecimal in hexadecimal format. That means digits from 0 to 9 and letters from A to F. And that's basically an Ethereum address. It has to have a certain length, but this is the identifier of an Ethereum account. This is important for now. So about Ethereum history a bit. It was proposed initially through a white paper by Vitalik Buterin, and he was working as a writer for Bitcoin magazine, and he liked the blockchain at the time or the technology behind Bitcoin, and he proposed to extend it. But because Bitcoin community is more conservative, meaning they do not accept changes to the software as fast as, let's say, in a traditional software product or software service, he decided to propose a new type of general purpose blockchain that would allow to create something that's called decentralized applications, right? So think of Bitcoin as being a phone, meaning you have, let's say, a normal cell phone without applications like the old ones, Nokia's and so on. And Ethereum in this case is a smartphone for decentralized applications, right? You can install apps on a smartphone, and just like that, you can install decentralized applications on Ethereum. And in a way, the phone functionality from traditional cell phones can be replicated in a general purpose system like a smartphone, right? So the same way Ethereum or Bitcoin can be replicated on a general purpose blockchain like Ethereum. So we can write Bitcoin in terms of Ethereum and run it on Ethereum, or not it actually, but a similar token that looks like Bitcoin. We can write it and run it on Ethereum. Okay, and what gives this to us? That means that, first of all, you have a blockchain that can run not just one application, like an old cell phone that can only be used for calls or short messages, but you can do any type of applications. And besides that, it helps, or what it means in blockchain terms is that if you want to create your own cryptocurrency, you don't have to gather a separate network of miners. You don't have to convince people to secure the network separately. So you have the miners on the Ethereum network, they secure the network, and the applications that you write on top of the network will be secured by the same network. You do not have to fork the network, how to say. So for example, when they've created Litecoin, they copy-pasted Bitcoin's code, they've changed a few parameters, and they convinced people to mine Litecoin. But that was a separate network, separate miners with separate incentives, another world, basically, totally disconnected from Bitcoin. Good. And how we do that? We do create decentralized applications by writing smart contracts. And smart contracts are a way of saying, like, they're basically like legal contracts. You can think of them like that. But there is no authority that, like, I don't know, a court or of justice that follows that the contract is people comply with the contract, or two parties comply with the contract. So we only have code in there that checks that people follow the rules while using the system. And for smart contracts on Ethereum, we use two languages. That's Solidity and Viper. Today we'll use Solidity, and it very much functions like you have an idea of a decentralized application, you write the smart contract for it in Solidity or Viper, and then you compile that code, and that code will result in bytecode that is run on the Ethereum virtual machine. So very much like in Java virtual machine, or in Java world, like for example, you can write code in Java, you can run the Java source code with Java compiler and run on the Java virtual machine. The same you can write using the same Java virtual machine, you can write code in Scala or Scala code and compile it with Scala compiler and run it on the same Java virtual machine. So it's basically one platform for multiple languages in this case. Good so far. I'll just check the session and that everything is in here. Yes, so if you have questions, please ask them in Q&A section. Okay, back to the presentation. Good. So smart contracts. How to think of smart contracts if you, let's say, if you work with traditional or with database management systems like Oracle, and you at some point you want to write stored procedures, and you deploy those stored procedures on Oracle, then you can execute them later. It's the same thing. So we write smart contracts, we deploy them on the blockchain, and then someone can execute them later. And the thing that is different in here is the fact that the execution is replicated. What does that mean? That means that each and every node in the Ethereum network, and there are thousands of nodes, will run the same code. So if you invoke a function that does 1 + 2, then the same function will be executed by each and every node of that network in order to verify that in order to agree to the same state and to verify the fact that, okay, this is now it's the state of the network, right? Especially when it comes to state changes. And you would ask, okay, why would it make sense to execute the same code over and over and over again? So there are two advantages in here. So first of all, you do not have a trusted intermediary or trusted authority that let's say, holds control of the database. Let's say some database administrator that can go into the database and change the data as he wishes, as he pleases. Or if not just one person, you could have, I know, 2 or 3 people in a company that can come together and do those changes, right? And it's still considered centralized. And in this case, you do not need to have the trust in the one who runs the database, the one who administers the database, and so on. And the other thing is the fact that it's transparent. So every blockchain operation that you do is transparent. It's visible from everywhere, basically, on the internet. You can just go and query information, either from the Bitcoin blockchain or from Ethereum blockchain, doesn't matter. You can see what everyone has done, and it has some advantages for some type of applications. Good. And now we have this what's new, or you have this Turing complete versus Turing incomplete languages. That's in order to write a smart contract, you would need a Turing complete language. That means a normal language that supports loops, statements, especially loops and recursion. That's very important. There are also Turing incomplete languages that offer you a limited set of instructions, and you cannot just do any type of algorithm. So Turing complete means you can code any type of imperative algorithm in that language. It's that simple. And Solidity is that kind of language that runs on the blockchain and can support that property. Okay, about Solidity. So it's an object-oriented language. It's not as complex as Java and doesn't have as many features, for example, but it is object-oriented. And as we said, you compile it. It is a strong type language. You compile it. You get the bytecode from the compilation process, and you ship that bytecode, or you deploy that bytecode on the EVM. EVM is the Ethereum virtual machine, and that's it runs inside of every node that is part of the network. So you basically send the bytecode to the network, and the network will accept it if it's okay, and then you can use that bytecode to run functions in smart contracts. Good. Solidity has been first been used in Ethereum, but there are lots of other blockchains that are compatible and also support Solidity. And that's some of them are Polygon, Avalanche, Binance Smart Chain. And the reason they have decided to support Solidity is because until these new blockchains appeared, the community in Ethereum, the community of developers got so strong, and there were so many tools developed around Solidity that it didn't make much sense to create a new languages, right? So some of the new blockchains have their own languages, but usually people go where there are, and even from business perspective, you would probably go to the place where you have the most developers, right? So usually Solidity is basically the most popular language in general purpose blockchain. Okay, so let's take a first look. So I'll use an IDE that runs 100% in the browser. It's called Remix. Okay. So before we take a look at the code, let's take a look at the IDE, because we'll work with that. So you have the usual tabs, which a place where you explore the files that you have in your project, the place where you go to compile the contract that you write, and then the place that you will go to deploy, right? So files, compilers, deployer, and these are extensions. That's probably for another time. So let's take a look at one very simple smart contract. So you can see that it's very much like JavaScript. Let's take a contract that's a bit more complex. So you can recognize some keywords that you already saw in JavaScript or Java or other languages. Yes, but the only thing is that it is statically typed. That means if I have a variable of a certain type, I cannot assign it to another variable, and this protects you from making errors, or from a set of errors that you could make as a programmer. Okay. Then we have the language has evolved pretty quickly, so that's why they have decided to specify the version of the compiler to use to compile a certain file. So because the upgrades in the syntax and in the grammar of the language were so often, they have decided to put this this specifier, or is basically say compile this with Solidity compiler between version 070 and 090, for example. Okay, and then Solidity is a bit criticized. It's not necessarily that it has security flaws, but it's criticized because it allows too easy for developers to shoot themselves in the foot. So that's why it is very good to, when programming in Solidity, to also know the best practices to adopt when you program your smart contracts, and to test the contracts and so on. Because one thing that you cannot do to the contracts is change them. So you probably heard about the immutability of blockchain. So once I upload a contract, the source code of a contract to the blockchain, it's over. No one can change it. No one can go and correct a bug, an error. So that's why even the process, we'll take a look later, even the process of development of developing smart contracts looks a bit different than in traditional software as a service systems. Okay, cool. So yes, and let's look at the syntax. So we have the contract that's basically look very much like a Java class, let's say, or a C# class. Then you have functions and they correspond to methods or instance. They correspond to methods in Java, right? And you cannot have and then we have also properties or instance variables, and they're basically called state variables, right? Good. Then we have modifiers. We'll take a look at modifiers. Modifiers are very much like interceptors. So you can say that I want this method to execute, but please intercept the call and execute some other call. It's somewhat similar to interceptors from other frameworks or languages. And then we have events, imports, of course. So I would import some of the, we'll use these imports, but I cannot find imports in this contract that we're looking at. Okay, then you have the normal value types like Boolean, bytes, unsigned integer, assigned integer. Address is value type that is basically a primitive. Then you have a dynamically sized type like bytes, strings, arrays, and so on. Enums and all the control structures like if, else, while, do, and so on. Cool. Let's go through this part. Okay, and when we deploy a contract, let's try and deploy a contract. So I have this contract. What it does, it stores a number. That's everything that it does here. So I'll deploy this contract, and when I'll call the store function and I'll give it a parameter, it will save the value of that parameter into this field or instance variable in normal traditional programming languages, or in a state variable as it's called in Solidity. And then I can retrieve it later. So you can see it as a simple class that has one property and a setter and a getter. And let's go ahead and compile it. So I'll select the language version 087. That's okay. Now I have compiled the contract. I can see the bytecode of the contract in here. It's nothing interesting necessarily, but so it would look something like something like that. So it's just bytecode instructions one by one. We'll come back later to this. Good. Now we have compiled the contract. Now let's go and deploy it. Remix is a very nice environment for testing and for learning Solidity. So why is that? Is because besides the editor, it also has a compiler or the ability to compile the contracts. And besides that, it also has the ability to run and deploy the smart contracts to some environment. And it also has an embedded environment in browser embedded environment. So when I'll hit deploy here, it will deploy the compiled contract to the browser's environment, and it is very good for testing, right? So I don't have to go and deploy the contract to some real network at the moment. So I'll deploy it locally. Okay. Good. Now, since I have deployed the contract, I'll see the two methods, right? Change owner, where's the storage? Okay. No, I'm sorry, that's not the contract. Let's go back to the storage contract, compile storage, and deploy the storage contract. Good. So we see we can now have a interface that looks very familiar to, I know, probably Swagger. So like you would use Swagger with the normal APIs. And you can call a method, and or you can pass some parameters to another method and so on. So let's try and, I know, store a value, an integer. So by clicking transact, I have sent a transaction to the blockchain or to the locally running blockchain inside my browser. And this transaction has been mined inside this this locally running node, blockchain node, and then later I can retrieve it, and it's that simple. So, and in general, these are the two major operations that you can do with blockchains. Retrieve data, which is for free. You can retrieve any data anytime from a blockchain or from a node that you have access to. And then when you have to store, usually you have to pay a tax. You have to pay gas for storing that information, because that information is going to be replicated on each and every node. And that fee needs to go to the people who run those nodes and allocate resources for you to store your information on their nodes. Good. So that was about it. A very simple deployment use case. Cool. So how are you doing? Let's see. No questions yet. Okay, then that's good. Okay, so let's go to the fun part. Let's try and before we start creating our cryptocurrency, let's install a browser extension. So everything with this browser extension, it's something secure. Don't worry, trust me. This browser extension acts as a connector between the cryptocurrency in your wallet and the blockchain. And you can use it either to query the blockchain, like, for example, asking a node, okay, how many cryptocurrencies do I have in my wallet? Or you can use it to send transactions and make state changes to the blockchain. Like for example, I'll send some money to some tokens to Amalia, right? And Amalia will be able to query later her own balance. But for me, in order to make that change to the blockchain, to the state, to the consensus of the network, I will have to pay fees. Okay, so we'll install MetaMask, we'll create a wallet, and we'll use another network than Ethereum, because Ethereum is really expensive today. And then I'll ask you to paste your address into the chat. So these are 4 simple steps, and we can have a nice interaction and nice interactive workshop starting from here. So I'll paste this address, which is, or link to metamask.io, into the chat. So you have the link in there. Yes. Good. I think Hopin has some protection, but the idea, you see, metamask.io, type it manually in your browser if it doesn't work from the chat. Okay, and I'll do the same steps with you. So I do not have MetaMask installed on this browser session. I'll do it right now. So I'll open metamask.io. I'll go to their web page. I'll press download now. I'll go to install MetaMask for Brave. I run Brave as a browser. It is also available for Chrome, Firefox, and Edge. If you have, if you're on Mac, unfortunately, it doesn't work with Safari. Safari has a different browser architecture, and they just didn't bother to implement it separately for Safari. So if you're on Mac, it's best to have Chrome or Firefox or whatever other browser than Safari and install it in there. Okay, so I hit install MetaMask. It takes me to the extension web store, add to browser. Does some checking. Okay, so it's installed now. I'll pin it here. Good. Now I'll go hit get started, and I'll hit create a wallet. It asks me for a password. This password is only locally stored in the browser, so you don't have to worry too much, at least not for this workshop, about writing a very complex password that you forget later. So I'll write something very simple like QWERTY123. Oh, I have a password now to my extension, and there is a nice presentation video. I'll skip that. And I get to the step where it says secret backup phrase. What's this secret backup phrase? This is basically the access to my account. So this is why it's secret. Anyone who has access to this phrase has access to the funds in my account, in my Ethereum account, for example. For now, I'll just trust you won't steal my funds here. So I'll take this phrase, I'll put it in a notepad. And then I'll go to the next step that would say, okay, let's confirm the phrase. So in my case, it's delete, sorry, with theory, access travel, just run away. Okay, so why is the seed phrase important, and why are those 12 words? What are those 12 words? They basically encode the private key that has access to change the state of your account, right? So, for example, if the state of your account is that you have one Ethereum in your account, then you have, when you have these words, when you have access to the underlying private key, you can change, make operations. You're authorized to operate, like, for example, transfer the Ethereum to another network and so on. Good. So these were the first two steps. So let's make a quick check. So after you have installed the extension, you would have in the top bar, you'll have the ability to copy paste your address, and it's the string, the abbreviated string that starts with 0x and is below the account one. Okay, you can see it on my screen. So, and I'll paste it in the chat. Okay. So, did anyone follow so far? Good, good. Jolt, thank you very much for your address. Andre, thank you. Great, great. So we already have 4 people. Oh, cool. Wow. Good. Now I'll have to take these addresses and store them because I'll use VS Code because it's a better editor than Remix. Okay, let's see. We have one address, second, third, fourth. Okay, Paul is sending a donation. Thank you, Paul. Lynn. Let me see. Silvio. Wow, that's a lot of addresses. Thank you very much for your particular. Wow. We already have 9 addresses. 10, 13, 10, 11, 12. Oh, nice. This is an engaged crowd. Cool. Thank you very much. And there's one, of course. So I'll just put a marker in here so that I can see any other addresses. So just please go ahead and if you haven't installed it, and just go through these steps that I described earlier. Go to metamask.io, get started. I agree, pick a random password of at least 8 characters, save the backup phrase, confirm it, and then you can move on to the second step or to the third step. Cool. Another address, and then we're moving on. So 15 addresses, that's a lot. Cool. Great. Next. Let's go to step 3. Now, Ethereum network is very expensive today. If you go to, there are various sites that will show you how much it costs to send a transaction at this moment. So for example, if you want to send a given amount of Ether from to someone, you'll have to pay basically $4. If you want to interact with a smart contract that is more complex, you might need to pay or to make a payment in Ethereum that values, I don't know, more than $20, $30 and so on. And there are spikes. It's still not very congested. When the network gets very congested, it can go north of $100 for some interactions with different smart contracts. Good. So for that reason, we're going to use a network that is basically a copy paste of Ethereum. What they did, they have replaced the proof of work algorithm that currently the Ethereum network is based on, and that they made it faster, right? So it's much faster to have confirmations for a transaction, and it is much cheaper, but it is not as secure. It is not near as secure as Ethereum. But I personally have used Polygon as a very good way to interact when to experiment on a mainnet or production environment network, while the fees are very high on Ethereum, and they've been high for the past year and even more than 1 year. Okay, so to do that, we'll have to switch to Polygon. We'll have to go to quickswap.exchange, and I'll show you. Let me paste it into the chat. So we have QuickSwap. I'm not sure why it is. Okay. It just drops the HTTPS from the link. Okay, Dragos, thank you for the address. So I'll open QuickSwap exchange myself, and so we won't be exchanging anything right now. This is just a way to quickly add the Polygon network, or we'll be using MetaMask, but the same installation of MetaMask, but we will not connect to an Ethereum node. We'll connect to a Polygon node that is compatible with Ethereum, and it will function transparently, very much like Ethereum functions. So just open QuickSwap Exchange and go to the Switch to Matic button on the right side. Click Switch to Matic. You'll have, I'm not sure if you see my pop-up, because I'm not sure if the share screen captures the pop-up, but in this pop-up you'll have the ability to approve the data that is related to the new network. It will contain the name of the network, the URL to connect to one of the nodes and the chain ID. Just click approve and also switch network. And then you'll be prompted again and you'll have to click next and connect again. It's very, very simple. Okay. Now let's go back into my view of the MetaMask. Okay, so what we have done, we have added the Polygon mainnet in here. So you can see in the drop down, it's already selected. If you look at the other options, we had the Ethereum mainnet in here initially, and then we had Ropsten, Kovan, whatever. These are all the test networks on Ethereum test networks, and then we have the Polygon mainnet that we just added, and we'll be using this this network. Good. Let's see. Any other addresses? Okay, so you see the okay. So we have 17 addresses. That's a lot. Okay. You'll have to bear with me 1 second because I need to reinstall the MetaMask just to make sure that my funds are safe. So I'll stop the screen sharing. You'll still be able to see me and hear me. But I'll go through the process of reinstalling MetaMask from scratch. So please check that you have that in MetaMask you have switched to Polygon network or to Matic network or how it's called. So Polygon and Matic is basically the same name. Matic was the old name of the network and they have rebranded to Polygon. Okay, and now reinstalling my MetaMask with a new seed phrase. Okay, I'm done confirming the phrase. And I'll go again to Polygon network. I'm into quick swap exchange. Switch to Polygon network. Okay, and until I do that, you can go to MetaMask and click on the menu, the 3 dots menu on the right, and click account details. So what you'll see there is your address and the same address that is encoded as a QR code, and you can use that QR code to scan it with another device, with your phone, and send funds from your phone. And that's exactly what I'll do now. Okay, so I'm done creating the new address. And I'll switch on the yes, now I'm sharing my screen. So Henry, the reason I did stop that was because I wanted to secure my seed phrase. Good. Okay, so that's my MetaMask on and Polygon mainnet selected. I'll go to account details. I'll need to send some funds to my wallet, and then we'll continue because we need funds to interact with the blockchain. We need funds to the native value token of the network, which is Matic. We'll need that to deploy contracts, to send transactions to the network, to transfer funds, and so on. Good. So I'm scanning the QR code right now, and I'll send, let's say, 2.5 Matic. Okay. I have submitted the transaction, and now I'll have to wait until the transaction gets confirmed. My phone says that it is confirmed. Let's see what's happening in here. Okay, so I have received the 2.5 Matic to my wallet. Okay, the value is not that big, so this value is less than $3. And okay, we'll leave MetaMask for a while, and we'll come back later. Good. So let's write the code for our own token. So in order to, there is this standard which is called ERC20. What ERC20 is, ERC itself means Ethereum Request for Commons. And just like RFC internet standards are, like there is an RFC for SMTP protocol or whatever other protocols. And this ERC or Ethereum request for commons are basically propositions, add this to the network and so on. And 20 is just the order number. So like there is a 21, 22, 23, but they are not necessarily approve all of them. So someone proposes a change to the network, then the other approves. That's why it's the reason to this code ERC20. Okay, we have ERC721 for NFTs, but that's another story for another time. Good. So in order to not implement everything from scratch, we'll just use OpenZeppelin, which is the best library for writing smart contracts securely. And they follow all the best possible best practices, I think. So we'll go to OpenZeppelin contracts, and we'll find the default implementation of ERC20. So this is the standard for a token. Let's see what it contains. So we'll see that it is just a contract, just as the ones that we looked at in Remix. And it has some functions like name, which should give me the name of the current token, like symbol. We'll also need the symbol for the token. Decimals, total supply, balance of, which would return the balance, how many tokens of the current ERC20 token do I have, or do this account has. The account passed as parameters. Then we have the normal transfer functions. Of course, if you have a token, you want to transfer it to someone else, right? Good. So everything that we'll do, we'll go to go ahead and create a new contract. Let's say our token. So the first thing is to specify the pragma solidity. I'll just copy paste this. And I think I'll use current version. You have 0.87. It's fine. If you have questions, please post them into the Q&A section. Okay, so let's start. We always start with contract keyword. So this is our token. So I already have a contract that's compilable. It is as simple as that. Let's compile it. Okay, it works. But it has no functionality. I can deploy it. It has absolutely no functionality and does nothing. Okay, so I'll want to extend what OpenZeppelin did in here and override some of the properties. So I'll say that I want to extend ERC20, and For that, I'll need to import. Let me see. Let me find the. I'll just have to go and import the correct path. Except it's contracts token ERC20. 71 is for NFTs. So compile again, or just if you do Control S, it should it should compile itself. Okay. So what it basically complains about is the fact that the ERC20 inherited contracts has a constructor and I didn't override that. So I'll create a constructor. I'll say that. Okay, let's specify the. Let's take a look at the constructor first. So I know this by heart already, but I want you to see too. So ERC20 has defined a constructor that accepts the name and the symbol, which are the name and the symbol of the token. I'll do just like that. I'll say our token and let's say our key or coin or whatever. Our token and our T as symbol. Good. So that means I have called the constructor. Good. Now it compiles. What happens next? I want to mint the token. So they have implemented this ability to hold or to remember or to store how many tokens are owned by what addresses, or basically the balances of each address of a given token. I'll just go and find the mint function, which means create new tokens, and I'll call it from my constructor. And I'll hard code it in there. I think that's good enough for our demo. So mint. Okay, the account, let's say for now, MSG sender is the account that deploys the contract, or in general is the account that sends the transaction. I'll use my account to send the transaction. And then we have the next parameter, which is amount. So how many tokens do we want to create? Let's say 10,000 tokens. And I'll specify ether. Although this basically means that after this 10,000, after 10,000, there follows 18 zeros because by default the token has 18 decimals. Okay, so it's just a syntax sugar for that. Good. So we have the token, and let's compile the contract, and we're ready to deploy. So that's it. I have a token now. When I deploy the token, the constructor is executed once. I get in my account all the created tokens, 10,000 tokens. Simple, right? Imagine that some people are selling these things. Good. But now I don't want to. Let's make it a bit more interesting. Let's also add a function. So I want a new function that would distribute the tokens, because I promised I'll send tokens to you. And we want to distribute the token to an array of addresses, basically the addresses that you sent me, addresses, and given the amount, tokens. And what I'll do here, I'll just iterate through all the addresses, very boring and normal programming here so far. And what I'll do now, I'll have to transfer the tokens from my address to the currently address that is in the loop. And of course, a given amount. So I just call the method transfer from ERC20, which is the function. This function, which in turn it's calls another delegate and so on, blah, blah. But the effect of it is that these addresses will get that amount. Okay, let's see compile error. Yeah, yes, we need to specify the visibility. And yes, memory. So some variables are stored in storage and on the blockchain and some on memory. And now we're fine. Good. So now we have compiled our contract. Nice. We're ready to deploy it. Let's go directly to the blockchain. Now I'll use Remix to deploy the contract, but I'll select the environment as injected Web3. Why it is injected? It's injected basically. The term comes from the fact that MetaMask or an external extension can inject code into my my page. So it's basically connected with MetaMask, nothing fancy. And it said that it didn't found MetaMask. Let me just refresh. It's not. So when in doubt, restart it. I'll go back to the contract, to our token. I selected it. I'll compile it again. Good. Back to MetaMask connection. Okay, so now if you can see my pop-up, it will prompt me to connect my MetaMask account to the Remix website. And I just did that. Cool, great. Now, when I go and hit deploy, I will send the transaction to the blockchain, to the Polygon mainnet, to the actual blockchain. The constructor will get executed by the nodes that will take the transaction, that will put it in a block and blah, blah, mine it and so on, will also execute the constructor. And then after that, I'll be able to call the distribute method. But there is one catch in here, and the fact that when I'll have this contract deployed, anyone would be able to call the distribute method. And it's not very nice or not very secure. So I'll probably want to secure it somehow, put an if statement in there to see if I'm not sure if it's the transaction is coming from one address only, because I don't want to authorize everyone to call the distribute method. So I'm doing just like that. Back to OpenZeppelin, they have a thing for that. If you go to contract, access, ownable. Yes, so this provides a nice modifier, which if you remember, I talked about modifiers that are basically interceptors that execute the code that they engulf or surround, and then they give you the ability to run some code before that, and then execute the code on which the modifier is declared, and then some code after that. So we'll use ownable. So it's the same import statement, and the path is contracts access ownable. Says ownable. And good. Good. It's compiling. Now I have imported the ownable.sol, and now I can use the modifier. To use the modifier, I'll just go and specify just this, only owner. And there you go. I already have my method protected from being called by anyone else who deployed this contract. Declare. What's this? I have no idea what's happening here. Memory addresses, amount. If someone spots error, what the problem is in here? Come on. If you see some, I honestly have no idea why it doesn't work. Okay. Open super contract access ownable. So, okay, of course. So I have imported ownable, but I forgot to declare the fact that my contract is extending it. Okay, and now I can safely use only owner as a modifier. Cool, great. Now we can deploy the contract. Back to the deployment tab, I have MetaMask connected. It shows me the current address, so A84 is the same address as the one in the MetaMask. Okay, I'll select the contract, our token. By the way, here in this selection, you'll be able to select all the contracts that have been imported, but we're only interested in the core contract, right? Okay, and let's deploy it directly on the blockchain. Okay, now I'll increase the gas fee so that we don't wait too much. And now we see that in the console, we see that the transaction has already been mined. So it says that with this account 84, I have called our token constructor and all the data related to the transaction. And there are different things in here. I'll show you. It's not that important. We won't dive into dissecting the transaction, but that transaction has a hash or an identifier, the account that sent the transaction, the contract that or the caller or the destination of the call. Then all the, in this case, we have deployed the contract, and we'll have also attached all the bytecode to the transaction. We can also see transactions from MetaMask if we go and use the blockchain explorer, which in case of Polygon is Polygon scan. Okay, you can see that it took some money from my wallet, some native currency, Matic, and I have a contract creation transaction in here. Okay, nice. Now I have the contract created, and that means that my token is deployed. Just as I have accounts in MetaMask, I also my accounts have addresses, just like in MetaMask. As I can see in MetaMask, also each deployed contract has its own address. That means that, or its own account. So a contract can store tokens or Ether or other native value currencies, just like normal accounts from MetaMask can. Okay, so all the tokens have been sent to the message sender, which is the account that I have deployed the contract with, which is this account. And now In order to see that, I'll just go and click and add token, or okay. So it already recognizes the symbol of our token, our T, and it has 18 decimals because I haven't changed this value when I overridden the constructor. And we have the 10,000 balance in here, right? Okay, so the tokens are in my account now. Now, what I'll do now, I'll send these tokens back to the contract. So I just wanted to show you that it is possible to store tokens in the account of a normal wallet that a person would use and in the contract that is entity stored on the blockchain. So I'll go again and pick our contract address, and I'll send all the tokens to that address. So our token, I'll send the entire amount of our token to the token address, token contract itself. Good. Now I have the transaction pending. Anything in yes, questions related to ownable. I'm sorry because I cannot answer questions or react to questions on the spot, but that's because I have to switch from one window to another. Yes, Alexandra asked if don't you need to call ownable constructor to save the sender as owner? Yes, that's true, and that's exactly what ownable does itself. Good. And I assume in here, it happened in here. So my contract has called the constructor by default. Good. Now I have sent all the tokens to the smart contract that we have just deployed. And if I'll go to the address of the smart contract that I have just deployed, I can see that it has 0 matic and it has 10,000 hour token. Cool. Now, finally, we can go ahead and use this smart contract. And what, besides all the methods that are inherited from Ownable or from ERC20 and so on, we also have our distribute function, right? That's the function that's supposed to distribute tokens to everyone who sent their address. So I'll go and call distribute function. I'll paste all the addresses that you gave me, and I'll send you a given amount of tokens. So we have 10,000 ethers and 10,000 with 18 decimal zeros, or that much. Let's say I'll send, if there are 20 addresses, I'll send 500 each. So that means this is 1,000, this is 100, this is 500 each. And now I would need to go to VS Code. Not this one, this one. And I'll need to format this a bit, so that MetaMask would accept it as an array. Not MetaMask, sorry, Remix would accept it as an array. Okay, so these are the 17 addresses that will get 500 tokens each. I'll go and call the distribute method with those addresses and 500 tokens each. Let's see if it works. I'll go hit transact, which means sending the transaction. I'll increase the gas fee a bit. And it already calculated that how much it would take me. And now we have sent the transaction. Good. So now, if you go to MetaMask, and hit add token, just hit add token and put this address in there. This is the address of the contract of our token. You will see that you will get you should see your tokens in there basically. Okay, so anyone received the tokens? Yes, okay, cool. Let me do this in here too. So let's go and see how many tokens are left in our contract. I'll go and hit balance of this account, and I see that there are still 1,500 tokens. I'll send one to my address too. So I'll go and I'll hit distribute again, but only for my address. Or actually, let me create another one. So in MetaMask, you can use the same seed to create multiple accounts that have different addresses. So in this case, I'll go and send tokens to this address, which is my second account, and my first account, which is this address. And the usual commas, quotes, and quote, comma. Cool. I should have added them. I didn't include myself. So I'll do that so that others who haven't added their addresses can also see what happened in there. So I've sent the transaction. It will just executed the distribute function that took my two addresses and the amount parameter, which corresponds to 500 tokens, and transferred the from the balance of the contract tokens to my MetaMask address, or to the accounts that have been added or managed by MetaMask. So now I have 500s on my account 1, and I have 500 tokens on my account 2. If I go and add token address, the one that I pasted into the chat, so this is the second account. It also has 500 tokens. Cool, nice. Let's see questions. Other questions, other curiosities or things or that you'd like to share maybe? Okay, but let's, for example, I'm in my second account. I'm not able to send tokens to my first account. Why? Because I don't have anything of the native value currency. I don't have Matic. So let me also send you some Matic in here. So to do that, I'll just go and create a new contract. Just copy this. Distribute Matic. Contract distribute Matic. Okay, and what I'll do, I'll just write a constructor. So that's how it's usually done. So When you deploy a contract, you can also send native tokens to the contract during deployment, and then that contract has the ability to use that value or that amount of native tokens to, I don't know, to have access to them, basically. So I'll take address, let's say memory, some addresses, all the addresses that you've sent. I'll want to send you a given amount of tokens. And how I do that again, just a for loop. Zero, six, okay, and now the function to transfer is the address.transfer, and that's usually done. I need an address, and it has an embedded transfer function. And that transfer function will basically send the given amount. Now, there are 17 addresses. What I'll do, I'll send one metric to this in this transaction during the creation of the token, and the rest of the money will be sent back to my account. So I don't want to leave it in there. So I'll go message sender. It's basically my address. Transfer back the remaining balance, and the remaining balance would be this address balance. Good. Let's see what's. Yes, so addresses need to be declared payable, and also this is a change since some version of the contract of Solidity. Okay, and it also complains that there is another address that is not payable or something like that. I think it's written this way. Yes, so from version 8 dot, I don't remember which one, you need to declare all the addresses that are payable so that you don't by mistake send Ether or native value tokens to a contract or to address that you don't intend to. So it's like a protection mechanism. Good, nice. Yes, I'll post. A question was, can you post the link, the GitHub link to OpenZeppelin? I'll do that now. You can have it in here. Of course, hoping drop the HTTPS. Good. Okay, and let's see what I can do. So I'll take, this is compiled, seems to be working. Let's deploy it. I'll use the same address to deploy the contract. I'll send one metric to it and as parameters to the constructor. So the constructor runs only once when I deploy the contract, and it never runs again. So normal, right? And to the constructor, I'll pass all the addresses and then the amount of tokens that I'm willing to send you. So this is a very small amount, but it's enough to run a few transactions so that you can experiment later. So one Ether or one token. So for example, let's see how much it takes to send one transaction. So let's say So it would probably take that much Matic to do a simple transfer. And that much Matic is, if I go to this quick tool, not Ether, but ETH converter, very simple tool. I could have written a script for this, but okay, so it's that much in lowest denomination. But let me send you for at least 5 or 10 transactions. So let's do this. Okay, so that much Matic I'll send to each one of you who provided the address. I'll put the amount in here. I'll go and pick again the 17 addresses. And I'll send that 0.00, I think it's 3 zeros and 5 Matic to each one of you. Good. Let's do this now. Okay, it's usually not recommended to go through iterating on dynamic value arrays because you cannot estimate how much gas it will cost you. So it basically tells me that I'll send that much Matic to satisfy the fact that I want to cover this one Matic plus all the gas that is necessary for it. Good. Seems to be working. Cool. Okay, so you should check and you should have some Matic into your account. That's enough. And now just go have fun. Just send the tokens, whatever. Pick an address. Let's say I'll take my account 2 address and send to someone from the list. Someone send some tokens. Be generous. I'll do that just now. I'll go to the chat. I'll take someone's address. I'll put it in here and I'll share a part of my tokens. There we go. Transaction pending. For some reason, MetaMask doesn't refresh the state too often. But as soon as my transaction is confirmed, that person would get tokens into their wallet. Okay, so that's about it for this session. Okay, so we have a question. Could you be more specific on what exactly does last line of code from the last contract? Yep. Sorry if I passed through that. So what this does is, okay, so we have clarified that this for will take all the addresses and send a given amount. That's clear. But now, when I have deployed the contract, imagine that this contract stores the value that I have sent it to it, right? So when I've deployed it, I've specified value. Value is an additional property that you can add to your transaction when you, for example, deploy a contract or call a method or so. And that's why the constructor of this contract has to be payable. So basically, when I set this value, it means that after it deploys the contract or during the deployment of the contract will own 1 Ether, or in our case, 1 Matic. So one matic will be stored at the address of the deployed contract. And then from that one matic, I'll transfer the given amount to all the addresses from this array, correct? But there is also change left in there, and I don't want to leave that change into the contract. I want to send it back to my address. My address is MSG sender, or the sender of the transaction that deployed the contract, and I'll transfer the current balance of the contract address. This is the current balance of the contract. So in short, it's to send back all the remaining, the entire remaining amount. Okay, cool. Cool, nice. So one more thing I want to mention. So usually it's the topic is large. We didn't manage to talk about how EVM works, what's gas, how the development process for smart contracts works when you develop a DApp, and lots of other questions. But we have Cluj Ethereum Developers Meetup, and that's what I want to promote. And the next meetup is going to happen on Wednesday at 5 p.m. Next Wednesday on 5 p.m. And just go in here and subscribe. If you found interested, if you found this session to be interesting, we do a lot more session in Cluj Ethereum Developers Meetup on the same topic. And what we are trying to do there is build a community of people from Cluj, locally, also except of course people from just joining online, not necessarily to be local, but we are trying to build a community of people that are interested into development on Ethereum and Solidity. So going there, the next session will going to be about NFTs, and we'll take a look at the source code behind the NFTs. How do you actually code an NFT? What's the thing in there? What's the code in there behind it? Just as we look today at normal tokens, cryptocurrency tokens, we'll look at NFTs next time. And that's about it. So I encourage you to join Cluj Ethereum Developers Meetup, and see you at those talks. And but until then, have fun at Techsylvania, and I'll be around. So if you want to have a chat, just ping me.
Thank you so much, Alex, for the session. It was great. And guys, if you still have questions for Alex, find him in the chat area or shoot him a message to take the conversation forward. Thank you so much for being here, everyone.
Thank you. Bye-bye.
Thank you. Bye.